Welcome to the fourth video on measurement for this term. This one's about surface area. Once again, some of the content you'll see here are things you've seen before in grade 8. This is probably the more challenging one that we come across, and it's mainly because it's difficult for some of us to visualize what's actually happening, what the shapes are, because the faces of our 3D objects are hidden. So our learning goal here is to use our knowledge of our 2D shapes and area to calculate surface area of prisms or 3D shapes. So let's define what a prism is first. So a prism is something, or a solid, a 3D object with a uniform cross-section. So that cross-section, if we have a look here, means we cut straight across parallel to the base, and the shape there is the same as the one at the top or the bottom. Okay, these are called right prisms because they form right angles to the ground. So that's a right angle there, right angle here, right angle here. They stand straight up and down. So in the rectangular prism here, we cut across parallel to the ground, we end up with another rectangle there, which is the same size and shape as the top and the bottom. For our hexagonal prism, cut parallel, we get a hexagon on top, bottom, and then that cross-sectional cut. So that's the first thing we need to know. It's very difficult to work out surface areas of objects that are not right prisms. Let's move on. So for a rectangular prism or a cuboid, which includes a cube itself, cuboid basically means this sort of rectangular prism box-like shape. What we have are two faces on each side that are the same. So we have a top and a bottom there and there that are the same. To work out the area of one of those shapes, it's that side multiplied by that side, or length times width. Because there's two of those, we double it. Similarly, we have a right side and a left side hidden on the back. They have a length and a width there and there. Length times height. Since there's two of them, we double it. Let's change the color again. Let's do green. They've got a front face and a back face there and there. They have a length and a width, and that width there is the same as that one there. It's the height. So the width times height gives the other face. We'll double it because it's front and back. So that's our rule for surface area. You can learn it, or you can just recognize the different shapes or faces. If we unfold the box, it looks something like this. Okay, so if we start with our green one there, we fold it from there. The next square is this one here, which was our red face. There, and on the other side, there. And then we go to the green face after that. So recognizing how they fit together. The two green faces, the front and back, the front and the back there and there, are not attached directly to each other. There's one face between them. And the other one we have is our top and bottom. So those two there are attached to the green bit on those two sides. This is the challenge, is visualizing those nets. So that's our net. It's not a requirement that you have to draw a net to work out surface area unless you're asked to. But some of us will find that easier to visualize and look at there. So here's a question. This is a fish tank. It has a length of 50 centimeters. It's got a height of 24 centimeters and a depth of 20 centimeters. We want the surface area to know how much glass there has if it has a lid. So it's got a glass lid as well. And that's what we need to work out. So read the question carefully to make sure you know all the information. So basically, we're looking at each pair of dimensions. So front and back, top and bottom, left and right. Top and bottom, front and back, because there's always 2 of each, we double it. There's the top and bottom, front and back, left and right. We multiply them together and add each of those to give 5,360. It is possible to work out area 1, area 2, area 3 separately. So that goes there, that one goes there, that one goes there, and then add up all the corresponding sides if you like. When we don't have a cube, it gets a bit more difficult. So what we have here are 2 shapes. This is a equilateral triangle on the bottom, which means all 3 sides are the same. So if we look at that shape, we've got the front and the back. Because it's an equilateral triangle, these rectangular faces are all the same. So we have 2 triangles. Let's check that TI to correspond. 2 triangles plus 3 rectangles. If we were to draw a net of that, it would look something like this. If we unwrap those rectangles around the outside, they fit together like this. So we've got 3 rectangles there. And attached to the end of those are our 2 triangles. Once again, not required to draw the net in this case. What we do need to remember though is that to work out area of the triangle, we need the perpendicular height. So let's look at that question and the solution. So area of a triangle is base times height over 2. We substitute in the base of 4, that's the equilateral sides, and the height of 3.5. Work that out. 4 times 3.5 divided by 2 is 7 square centimeters. Notice this time I'm working out each individual shape separately. So then we have our rectangle, length times width. Now the rectangle, if we go back and have a look at that, the rectangle sits here and has a smaller side of 4 centimeters and a longer side of 18 centimeters. So 4 centimeters on the shorter side, 18 on the longer. So we substitute them in. 4 times 18, our length times our width, 72 square centimeters. It doesn't matter which order we multiply them in, because as you recall, 3 times 2 equals 6, 2 times 3 equals 6. When multiplying 2 numbers, it doesn't really matter the order. Now because we worked that out as, just bear with me, as 72 square centimeters, we can just substitute them in. So we've got our 7 centimeters there, it's the area of the triangle, and the area of the rectangle is 72. We've got 2 triangles and 3 rectangles. So that's 2 times 7 and 3 times 72. Gives us 230 centimeters squared. Now surface area is just area, so we square it again. That's our unit. Okay. The next type, this may be new, is about a cylinder. So cylinder is still just a prism. It's a circular prism. So if you cut it across there, in the middle, parallel to the ground, it has a circle shape, the same as at the top. Now if we unroll that prism, we end up with this. You get a rectangle for the outside bit attached to a circle. Now because this rectangle strip here wraps around the circle, if you wrap it back around like that, we know that it has a length of 2 pi r, which is circumference. So what we have is the area of a rectangle and the area of 2 circles, the top and the bottom circle. So area of a circle is pi r squared, this bit here, and we double that because there's 2 of them. And then this bit here is length times width, and the length equals 2 pi r multiplied by the width, which in this case is that side, is the height of the cylinder. So that's your formula. You can learn it. Some textbooks also write it like this. 2 pi r outside of r plus h. And that's just the factorized version. That's a common factor in both of these terms here. Okay, up to you which way you learn it. I like this one because it lets me build it from scratch. I don't learn the formula off by heart. I remember what it looks like. I remember that there's two circles. That's 2 times pi r squared. And I remember this is a rectangle with circumference wrapped around the outside. So here's an example. Once again, surface area, this time of a cylinder. We need to make sure we have the radius. If you're given the diameter, you have to halve that first. That's our formula. So r equals 2, h equals 3, and don't forget our units need to be in the same unit of measurement. So here's our formula, 2 pi r squared, 2 lots of the circle, plus the circumference times height. Substitute the 2 in here for our radius. Substitute here for radius equals 2 and height equals 3. Type it straight in your calculator and you get 62.8 square meters. As before, there's a variety of questions for you to try. You have for beginners, these are straight single shape questions or simple shapes. Moderate questions are where I'd expect most of us to be starting. They have slight variations or they're more complex objects. And then you've got your challenge questions, which is where I'd like everybody to be getting up to. For those who want a real challenge, question 19 is fantastic to have a go at. Enjoy!